So I'm gonna go over how you would typically, or the process you will follow when you are fixing. So I will try as much as I can um, to narrow down, or I'll try as much as I can to only be this device specific, because obviously we are fixing a 16 inches M series. Some of what I will say here, well, you can use them in other devices, and obviously some of them will be this particular device specific. Okay, so before you start to work on this device, the first thing you want to make sure it's the charger. You want to make sure you use a 120, 140, 140 watts. That's the first thing that you need to. That's the first thing that that's where you want to start from. Your troubleshooting charger has to be 140, not less than that. Now, one of the reasons why that is important is because it is not that if you use something less, say for example 96 watts, it's not that it's not going to work. But remember, this is a situation of you're trying to fix a device, you're not charging the device for usage. So you don't want to have and 9 out of 10, usually when you're troubleshooting a device, for example, you have the logic board out, which means there will be no secondary power supply. There will be no secondary power supply structure that usually will come from the battery. So you want to make sure that you have a 140 Apple original charger, not generic original charger. Then the next thing is, the next thing you want to do is you want to make sure you have a safety cable. Let me just see this safety cable. Did you take the safety cable? No, no, no. What about mine, the white one? Okay. So you want to make sure you have a safety cable. Just do this. Now, you can use a Type C. Yes, not a problem. However, the safety cable, it gives you an easy narrow down. For example, if you connect and then you have communication on your Type C, I mean, which is the LED comes on, it gives you an idea of the state of the device, where you are, the rails that are present and the rails that are not present. Just gonna do this. So, so just it's best, especially when you're working on 14 inches, 16 inches, to make sure you have a safety cable. Why? Because it's easier in your troubleshooting. Communication on your charger gives an idea where what state the device is in, and then you can obviously continue from there. So I recommend you have a max safety cable. Okay, that's that. And then also, while you're working on these devices, it's also good if you have a device that you can confirm. Say, for example, when your charger is connected, because it's important when you're working on these devices that every stage that you get to, you don't have doubt in that stage. So every stage that you get to, and then you want to go past it, you want to make sure there is no doubt in that stage. What do I mean by that? You don't want to have doubt as regards to your power supply. So it would be good if you have a secondary device around that you can just confirm that indeed that your charger is properly connected and is working. So what I'm going to do is I'm just going to connect this to it just to see. Okay, we confirm that is working. Okay, so now we confirm that we have a working charger. Now, if you're going to use a Type C, in situations where you're going to use a Type C cable, you also want to have something that you can connect it to, just to confirm. Because again, like I said, you don't want to have a situation whereby you are troubleshooting on the basis of you not being sure of what's the state of your power supply. Because remember, the action that you take is dependent on your current state, correct? I mean, if you say, for example, if you have no PPDC in, you will obviously want to start from, why do I not have my PPDC, which is your primary power supply onto the device. Okay, so that is that. So we have established that, and then we confirm. I'm just gonna just leave this here. In this cable, I need to fix this cable, otherwise it's just gonna annoy me for no reason. Okay, so and let's see which one is that. This cable is starting to annoy me. I don't understand why it disconnects on every. Why does it shake for no reason? Oh, why is it doing? Let me check the back. Um, so I spoke about making sure that your charger is fine, making sure you are able to confirm that your charger is you're getting the charger is in a working state. It's not something that you have to doubt. So and even if you are using a Type C cable, make sure you have something just to confirm that your charger is working, so that you don't have to work in doubt. Okay, so that's it. So now the next thing you want to do is ideally before the board has already been taken out, but then before the board was taken out, you want to plug in your Maxi 3 cable just to see if you have communication. Now this has to be the reason. If you're using a type C if you're using a Maxi 3 cable and it's an original cable, and you're also using an Apple original brick, then there is no the chances of you damaging the device through over voltage will be very slim. So which is why, especially when it comes to repairs, make sure you use an original Apple charger. The cable and the brick has to be Apple original. So I mean, you don't want a solution whereby you have a voltage surge, because when it comes to non-Apple chargers, there is no proper regulation in terms of the voltage. So whatever comes into the brick is what goes out of it. There is no type of regulation, what have you. And usually there is no proper negotiation between the charger and the device. But then if you're using an Apple original charger, there is proper negotiation between the charger and the device. Now, by proper negotiation, what I mean is so the device, the charger will put out the required voltage only when it is in only when the receiver, in this case the device, is in a state to receive or to receive the voltage. Okay, so I mentioned that even if it's a Type C cable, make sure you have something that you can connect it to, just to be sure that yes, you have voltage that is coming from your charger. There's nothing to worry about on the charger. And then the next thing now has to be your charging port, the charging port that you're going to use. Be sure that now oftentimes, especially when usually when you have this is common with the Type C chargers. So Type C chargers oftentimes with older devices, not necessarily older devices, but with dual charging ports. I'm going to show you. So these are single charging ports with dual charging ports like this one. So oftentimes what happens is, so if you look at this, I'm not sure if you're able to see that. So if you see how that is. Now this is from a device that had a faulty CD32. Now, if you look at that, so usually that is how you tell. And then also this is also it is also important. Say for example, if you worked on a device that one or both CD3215 were affected, it's best that after you finish doing the repair on that board, that you check the CD30, the charging port. Obviously you have to remove it from the show in order for you to see, just to be sure that the pins are healthy. You make sure you have healthy pins, so like this one for example. So if you look at, so one side, this side is a little bit okay, but the other side you can clearly see. So now you see the difference. So this is not healthy, but these are healthy pin outs. So you want to take it out just to be sure that that is the pins, the charging port pins are fine. You don't want to put it back. And also, when you also find, if you do find a situation where you have something like this, it's also good that you advise your client that they should not reuse whatever charger that they were using for, just to be on the safer side. Okay, so that said, now after you have obviously confirmed that you have a working charger, you before this is removed from the shell, you plug in your Maxif 3, because that will give you an idea once the device is in, and that will give you an idea. That will give you something to build on. So we are going to do that even though the board is out. We are going to check to see if we have negotiation on the Maxif 3 port. So we're going to do that. We just need to connect it like this, easy. In order for this to work, now there are certain peripherals that in order for them to work, they need other peripherals to be connected. When it comes to a Maxi 3 cable, you just need it connected. Nothing else needs to be connected for it to work. Do you understand? So, which means you can just plug your charger in just to see if yeah, if you get in. So say for example, if this is a MacBook Air, MacBook Air has a primary DC jack and a secondary DC jack in form of a cable, correct? So it will have this and a cable. Can I have a cable? You cannot see what I'm holding. What are you looking for there? You don't know what cable. No, it's very bad, eh? It's very bad, and that's very disappointing also. So what I'm trying to get at is when for this this is the same at a 14 inches and a 16 inches. I don't need anything extra in order for me to confirm the working state of my Maxi 3 port. I'm just gonna disconnect that. Now, the reason why I had to mention that, so I'm saying the only thing that is required is the logic board itself and the Maxi 3 and the Maxi 3 cable. That's the only thing that I need. Now, the reason why I had to mention that is if this was a MacBook Air board, now this is going to be the primary DC jack, and this is going to be the data cable. Now, with the MacBook Air, if I am to connect this to my MacBook Air board and then I connect my MagSafe 2 to it, I'm not going to get communication on the charger. Why? Because the cable is not present. Now, that design is not the same as this. So I don't need anything else connected when it comes to my 16 inches or my 14 inches in order for me to get the charging communication on my MagSafe 3 cable. Do you understand that part? Okay. So that's why I had to mention that there is nothing else that's required. All you need is just to have the board and the DC jack. So I'm going to connect that, and obviously in your connection, and this thing is also very important in your connections. Make sure that you confirm that it's properly connected. It's properly connected, because I mean these things might be very small, but then if they're not properly done, you might be making a simple mistake, and then your judgment will be based on that mistake. You might think, okay, I don't have a Max F3 communication, I have a problem. Whereas the only thing is the cable is not properly connected, it's not properly plugged to it. Which is also why when you're doing repairs, be sure that you are in a good state of mind. You know what you're doing. You're doing less talking and more of following up what you're doing. Especially if you are assembling a device, if you are very good. I mean, if it's become part of you, then you don't necessarily have to be so. So if you're very good with opening and closing devices, it's basically kind of part of you. Then you don't have to be so focused when you are obviously doing the assembly. But even at that, obviously you know yourself better. You will know if you are the type of a person that you sometimes just skip cables, and whatever it is that will make you, obviously when you've been doing this, you will know some of the issues that you have in terms of your shortcomings. So you would know, okay, for example, if I plug a cable into if I plug a cable in and I did not close the latch, sometimes I tend to forget. So then what I would then do is I don't plug in all the cables and then later start connect closing the latch. So what I'm going to do is I will make sure that I plug a cable and then I close the latch at the same time. So you know yourself better, but whatever it is that works for you, that is what you should follow through. So we come back to the DC jack being connected. So just make sure that this DC jack is properly connected and make sure you are fully aware of what you're doing. And while you're doing this, you are following a pattern. You know what you've done and what else needs to be done. Okay, so that is that. So I'm just going to connect that, and then I'm going to see if I have communication on my DC jack. There's a 3 cable, so let's connect that. And then another thing I want to say again, Alex. I said help him install the battery. Hold on. So the thing with when you're learning, you have to try as much as you can to have questions to ask, because at the end of the day, when you are doing the repair, I'm not going to be there, and there are certain things that I will be so frustrated to see that you are doing something completely opposite of what you've been taught. Okay, so we followed the process down to this. Okay, so now we confirm. And then another thing I wanted to mention, for whether it's your type C cable, or your max F3, usually they will have A and B. So A and then B. Sometimes your A will be fine and then your B will not be fine. Say for example, sometimes um, your A1707, just an example, A1707, it has four CD32 15s. If one of the CD23215 fails, depending on which region of the CD32 that has failed, it may prevent the device from booting up. So usually one of the ways you would know which of the CDs has failed will be that yes, you get in 20 volt across all of the port, but in one, in say in A will be fine, but B will not be fine in just one of it. 9 out of 10 is one of the three. If you have two failing in or four, then 9 out of 10 is not going to work. But if you have one of four failing, then oftentimes, depending on what section of or what region has failed, it's still going to work. But then one of the ways you can tell that you're having an issue with that particular one which needs to be replaced is when you plug it in this direction, it works, and then when you plug it in the other direction, it doesn't work. Like, I'm talking about your USB-C now. That's just something to also have, to bear in mind that you will have A and B. Okay, so let's connect and see what is it that we have. So let's see this. And then another thing is, okay, so yeah, that's it. So another thing is whenever you connect these chargers, especially if you're using an Apple original charger, expect a slight delay, correct? And that is because the negotiation is taking place. Expect a slight delay. And that's also one of the ways I'm going to disconnect this and then I'll get back to the behavior. That's also one of the ways you can, I did speak about this, I don't know if you remember. That's also one of the ways you can confirm, or that's one of the ways you can differentiate between an Apple original charger and a generic charger. A generic charger, when you connect it to the device, there will be no negotiation to take place. It's just going to initiate communication immediately. But then when it's an app original charger, there will be negotiation taking place. Uh, Part of that negotiation is to make sure that the receiving end, in this case, the what is it called, the logic board is in a state where the charger can put out voltage to it. Okay, so that's fine. Now we just saw that we connect charger, and then we see that we have communication, which is it's kind of looping. So it comes on and then it goes back off. Now this, what this is doing now, this is looping, so I'm just going to disconnect it. So what it's doing is the charger is connected and it's trying to establish and to establish completion, it needs to get to 20 volt. Sometimes you depending on the type of multimeter you have, you might get 20 odd something volt, not directly 20 volt. Now, so in that, now the usually the completion phase of this charger would be that you have 20 volt established and it's stable. However, if there is an issue down the line, The charger will try to negotiate 20 volt, but then because of the negotiations that I told you takes place, when it finds an issue down the line, one of the power rails is an issue with one of the power rails. What it will do is it will do what? It will stop and try again, stops and try again. The idea is when it tries again, it hopes that that issue has been, it's a machine, it doesn't know that there is a fault. Yeah. So it's going to stop and try again. Do you understand? And usually those are what will be designed or referred to as feedback, correct? So it needs to see what's going on after the communication has been established. Now the feedback, it's what reports back to say, okay, no, there is an issue down the line. Now through that feedback sequence, through that the feedback negotiation, then it goes off and try to establish communication again, which is why we see that we get on and then we get off. So the next thing we're going to do after we've established that, now this information that we have now, if you're going to use a USB-C cable, you might not be able to catch this information. This is which is also why I say that it would be good that you use a Type Maxi 3 cable, and make sure not only a Maxi 3 cable, an original Apple Maxi 3 cable. Do you guys have any question up until this point? We can move on. Okay, so now we know that we have an issue on the board. Now this issue can be of this can be a number of things. Okay, so I'm just gonna explain. Can I have a book and a pen? I'm just gonna show you guys something. So the issue that we have now, it's not like we don't have communication. We have communication, but then the communication starts, and then because of an issue down the stream, the communication stops, and then it tries again. So we know that the charger connection takes place on which power rail? PPDC in. Okay, so we have PPDC in. So this is going to be the voltage that is going to come from your charger. Now when now this is going to now this is now going to be interpreted, or this is now going to become equal to other rails that need to be broken into. So I'm just going to give you an instance. So let's assume that here we have AON, which is obviously PP3 underscore G3H. Remember G3H was for older design, correct? Which is always hot, which is, it will mean that this power rail has to be always on. Now AON, which is exactly the same thing, this is the same on newer devices, they use AON instead of G3H, now which would mean always on. Okay, now let's say we have that, and then we have PP bus, we have PP bus, and obviously you remember that PPDC in is also what is it's now going to is what would get broken down into PP bus, and then is what is going to get broken down into AON. And let's say again that let's say we have another 5 volt line from our PP bus. We have 5 volt line from our PP bus. Now, if I have, so what is happening now is this. So if we have an issue in one of the sub rail, what's happening? Okay. If we have an issue in one of the sub rail, so when I say sub rail, rails that are, so for example, if I put 5 volt, if I say PP bus, if I draw this line and then I put PP bus, 5 volt from PP bus, it means that this 5 volt is a sub rail of PP bus. PP bus is going to be the sub rail of PPDC in. Now, so when this is established, PPDC is established, now we get, for example, we get a breakdown of PP bus from our PPDC in. Now from our PPDC in, we're going to get 5 volt. If I have an issue on my 5 volt, which is a sub rail of my PP bus, it's going to be present. The reaction is going to be present here. So what will happen is PPDC in gets established, and then obviously you have PP bus, but then PP bus senses there is an issue. What happens is it reverses the process, and then what happens, it comes, basically there's a retrogression, and then it comes back, and then it tries again. Now until that issue is resolved on the sub rail, the that loop will continue. So now we don't know what the issue is now, so we're going to look into it. But what we're going to be looking out for is, we know that the fact that we have a stable LED at first, it means that there was an established communication. But then down the line, there's something that is obviously not okay. then because of that, it will try again in an attempt to now, this time that it should be fine, but obviously it's still not going to be fine because there's an issue. Okay, so that's it. Now this is obviously, so now just so that you know that this is just a sketch. It's not that PPDC in from PPDC in. Yes, PPDC in terms of if you're using if you're using a charger, PPDC in is going to be your primary voltage supply, which is now going to be distributed into and then broken down into every of the power rails that the machine will require. So, but what I'm trying to say is it's not how it's drawn here to say, okay, PPDCN is equal to AON equal to PB bus. This is just a reference. Okay, so now after, remember, we have now confirmed, we saw exactly how it behaves in the chassis. The next thing we are going to do is we will now take the board out, assuming the board is not out. Now, once the board is taken out, the next thing I'm going to do is I'm going to do a sweep. I'm going to do a sweep through the board to see if anything stands out. Before I start to make measurements, I'm going to do a sweep through the board to see if anything stands out. Because doing a sweep through the board, it's like it's a very easy way to spot if anything is not looking okay. So and then, but just something that I want to mention. Connecting a charger, that will only be a case of where you know that this is not a liquid damage device. If it's a liquid damage device, you solder the liquid first before you introduce power onto that unit. If it's, which is why before you obviously connect your charger to it, if you are not sure of the state of the device, it will be best to do what, to open up, to take out the back cover of the device before you connect power to it. Now this is whether you're using the Type C cable or you're using a Maxi 3 cable so far. So the next thing, let's now, yes, the board has been taken out, but let's assume the board has not been taken out. So now the next thing we're going to do is now to take out the board. After the board has been taken out, and again, if this is the first time you're doing this, or you are not so used to doing this, be very aware of the screws that you're taking out of the board. It's very important that you know. As a matter of fact, sometimes if you are not very confident of what is what, you can take a photo of before the screws are out, so that you will use that photo as a reference when you are putting the screws back and what needs to be what. Now you don't want to long screw your board. So basically you don't want to use a longer screw in a shorter hole, correct? So you want to make sure that each screw goes back exactly where they're supposed to be. And it's also very important that when you are putting the device together, take your time. Take your time, because this is the finalization stage of the device. Take your time, make sure that you double check on the device to make sure that everything, every clip, every lash has been closed and every cables has been connected. Imagine if you make just let's assume and then obviously there are some cables, or there are some cables that if they are not connected, you pick them up right away. For example, the screen cable is not being connected, you pick it up right away because there will be no display. For example, the trackpad is not being connected, you pick it up right away because there will be no trackpad feedback. And also the fan is going to spin very loud. But then cables like the power button cable, which is also the cable that houses your touch ID. That cable is a cable that you are not necessarily going to use while you are setting up the device, because when you start off, when you connect the charger to these newer devices, they act as they give the instruct they give the power instruction to the device, which would then bypass your power button, which is you're not going to use the power button. And because you're not the owner of the device, you're not also not going to test the fingerprint. So what you're going to do is you are just going to move on. So which is why and not only are the cables connected, especially the cables that need to be clipped. Make sure, yes, they are connected, and make sure they are properly clipped down. Because sometimes they are clipped to one side and then the other side is not properly clipped. Alex? In terms of those cables that need to be clipped, make sure, because sometimes, especially if you're not paying attention, one side will be clipped and the other side will not be clipped. And again, sometimes you have the speakers not properly being connected. Maybe one of them is connected and the other one is not connected, and you're not paying attention. The device starts, but you didn't really pay attention to know if the audio was synced when the startup sound. Or sometimes some devices, depending on what state the device is in, you might not actually hear the start of sound. Or also depending on the settings of the device, you might not hear the start of sound. And you might not know that, okay, yes, the start of sound not being present is not because of the state of the device, but just because, or the settings of the device, but because the speakers are not connected. And I imagine that device goes to the owner, and then who knows where in the world the owner is, and then upon receiving the device, now they find out that the speakers are not working. Imagine the logistics that will be involved in the device coming back to you if it's possible, and the cost of you having to foot the bill, or if the client is going to, or whatever happens, but it never ends well. The clients see you not to be professional. So these are stages, and these are things you need to take note of, especially when it comes to repair, and understand that these devices are sensitive devices, and people invest so much in these devices, and they give you these devices because they believe you know what you're doing. So at every stage of your repair, be mindful of what you're doing. Okay, so that is that. So where were we? We stopped at where did we stop? We're talking about the cables and the lashes. Make sure lashes are properly closed. Know yourself. Do not plug in a cable and leave the lash for later. No, go through it in an orderly manner. If you want to start from the right or you want to start from the left. The same thing with your screws. You want to start from the right or you want to start from your left. You make sure that your screws are properly placed in the right order. And at the same time, after all of that is done, look to be sure that every cable is connected and every latch is what is properly closed. Any questions so far? No? Okay, we continue. Okay, so the next thing is the body's out now. The next thing we're going to do is we're going to do a sweep through the board to see if anything stands out. We know the state of the board, which we have established using our what? Using our Maxi 3 cable. So let's now see. And like I said, there's some of the things that I'll be mentioning here you can use across other devices, and some will be specifically to your 14 inches and 16 inches. Okay, so what I'm now going to do is I'm going to start by sweeping through the board. You can either start from your right or from your left, it doesn't matter. So I'm going to start from the side just to see if anything stands out on the board. So after I do this, then the next thing I'm going to do is I'm going to go to the other side. And when you are doing this, nothing should be overlooked. Pay attention to anything, and if anything stands, if you see that something doesn't look okay, you want to obviously get a reference board just to be sure, and even if it means having to make measurements just to be sure that you are not skipping anything, because you what you see, it's really going to play a crucial role in terms of you being able to fix the device or not. I mean, because it basically helps speed the process. Okay, so I'm done looking this side. Now I'm going to flip the board, and I'm going to also take a look at the other side. And also, there are some components that you have to position the board in a certain way in order for you to see if there is any type of changes on those components. Sometimes, if you place the board just like this, you might not see them, but then when you place them a little bit differently, you will see. You will see. But again, because we're just doing a general sweep, we are not doing a pinpoint sweep now, so we might not. So yeah, so then if there is any need for me to show you what I mean by that, then I will show you guys what I mean by that. And this is a 16 inches board. If this was a 14 inches, there are a couple of sections that are commonly affected. And then another thing I'm going to also say on this one, I'm going to show you. So with 16 inches, you see this cover here. Usually you might have a bit of oxidation under here. So you want to remove that just to see it. And that alone can be your problem. Do you understand? So sometimes you want to remove that just to be sure. This is what I'm talking about here, not this. I'm talking about just that. Okay, so if this was the 14 inches, okay, so I think we actually see where our problem is. Hmm? So it looks like there was, just see if that's the only issue we have. So this side we find there, that side we'll find there. What we have, liquid in this section. Okay, so we are going to see what else is in that section. What is within that section? What is within that section? Hmm. Did you try to clean this already?
Yes, I cleaned it. It was worse.
So, was there any components there?
When I cleaned it, there was no components.
Okay.
This
Uh,
was heavy oxidation, too much oxidation charges.
this is liquid. This is not oxidation. This is corrosion. This is not oxidation. Okay, and then on the other side, let's see what's on the other side. Is there anything on the other side? Nothing on the other side. Okay, so what you're gonna do, let's just get another board to see how what is supposed to be there. If anything is supposed to be there, can we have the other one? Okay, so this is a reference board. So this is the section that's affected, and this is where we are, and okay, so that and that. Okay, it's nothing. This is not populated. That's not populated. So, not populated. Not populated. Okay, so now something I want to mention. So sometimes on a printed circuit board, you may find, say for example, this part here is not populated. Correct? Is not being used. Now, the fact that it's not being used and there is no component there, it doesn't. It could be that this is a connecting line. So what I'm trying to say is, so let's say we have this straight line and then we have populated. I'm going to use P. So P, N not populated, and then N not populated, NP or NC are not connected, and then I'm going to use P and P and P. Now this is a straight line. So let's assume that this P has communication with this P. But that communication, let's say the communication goes through this line, yeah, and then there will be a what? There will be a stop there. But though there's nothing there, but it goes through. So if there is a break here, if there is any type of oxidation or corrosion here, which will eat up away the part that's supposed to be here, what would then happen is the collision between this guy and this guy will be affected because there is a break here. So we might be having something like that, even though there is no component here. So it could be because now this is this is a current sensing resistor line. This is a current sensing resistor that is not utilized. However, remember, usually with a current sensing resistor, A is going to be equal to B, correct? So even though we don't have a pad here, so there is a chance that there's a line that is going through from here to here, which is not which has been affected. So the first thing we're going to do is we're going to clean this section properly, and then we're now going to open up our board view to see what that exactly is. And so we're going to be checking the parts. So some of the parts that are missing, though we are going to clean it properly to see which parts are missing and which ones are not missing. And then we would now make our measurements. So yes, there are no components there, but it might, even though there are it's not being utilized, but it doesn't mean that there's probably like a broken line or whatever it is. So let's clean that up and take it from there. Because sometimes you might be like, okay, man, I mean, there's no component here, so I should be fine. But yes, there is no component, but then you might have lines that have been affected. So let's clean that up and see, and then afterwards we open up our board view and see what is important and what is not important. That's another current sensor resistor. Yeah, you see, that's another one. That's another current sensor resistor part. So this is one, and this is another one. Whereas the current sensor resistor is supposed to be there, that is not there, and the pads seem to be affected. So Farid, you see this, you need to know what you're doing. You shouldn't attempt this because if you don't do it properly, you might just the pads might still be used, but if you don't put that into consideration, you might just be losing the pads that could have been used. So this while you're cleaning, you be very careful. Eh? Okay, so we also see that this capacitor is also affected from this side. So we are going to, let's see. Uh, so we are going to check if we have a short on that line. I'm just going to show you guys where we are. So this is a section here. This is a section that we have an issue around here. So this is the guy that I said this is a constant series. And I said, remember I said A is going to be equal to B. So you see here it says PP boss underscore NAND. So here is PP boss and then you have PP boss also. So and you see where it says ISNS, that's a current, that's a sense, that's a current sense resistor. So what's affected is RD 65 and also this guy here. So this guy here. So you see what I'm talking about. So even though there is no line, there is no component there, but then you have a meeting point, correct? So this guy here seems to be affected, which is a PPV in 3.8 volts land. So we are going to see if we have a short on that line. Hopefully we don't have a short on that line. Okay, so let's check that line because we have a capacitor that was affected, that's partially affected. So we are going to remove that capacitor. But before we remove it, okay, whether it's shorted or not, you are going to remove it. And then another thing I want to mention is with newer devices are extra sensitive. So when we talk about, so when we I would delve more into this in terms of there are some of with previous designs there's so many things that the secretary will overlook and will work regardless. But newer designs will pick that up as and see it as a problem, even though it might not be serious. But then there is more prevention built into it uh, compared to the previous ones, which is obviously because it's improved. So we are going to clean and then remove that capacitor, and obviously because that capacitor we're going to remove it and replace it. But then if you don't have a replacement, let's see how many of that you have on that line. Let's see if that can be. Okay, you have one there. You have one there. Okay, yeah. For this one, it would be good to actually to replace it. But sometimes you have capacitors that have others that serve the same purpose. When you remove it, you don't have to replace it. Okay, so let's clean that part of the board. Okay, so what I'm going to do is so I'm just going to check. So we know this is going to be equal to that, correct? So which would mean that this, if I am to measure communication between this line here and the PP bus line, I should get continuity, correct? Does it make sense? So I should have continuity. So if if I have a problem here, chances are that there could have been a break here, which would then mean that this will now be broke. This line will be disconnected from that line. Does it make sense? So I'm going to click on that. So I'm going to be measuring that, and then I'll check my PP bus, and I'm going to be measuring. So I'm going to put one pad there and one pad this. Okay. So I'll use any of those, so any of this part here, this guys. So which are this, so I'm going to use any of these guys, this part here, and I'm going to use this part. So just to give you an example, so if we this is our reference board, so we're going to set to continuity just to confirm continuity. We can also use diode mode, but we're going to use continuity for this. So I will have this here, and then I will do, okay, yeah, no, with this. So we get, so which means we have a healthy line. So we're going to do the same, we're going to carry out the same test here. Do you understand what I'm doing? Just to be sure that we don't have a broken line. So let's do the same thing there, do that, and then do this. You see our problem? You see what I'm talking about? So when I do this now, and I do this, we have communication, correct? But in this case, we do the same thing here, and we come here, we don't. So which means that there's a break between this section of the board. There's a break between this section of the board and this section of the board because of what happened here. Do you understand what I'm saying now? Which would then mean that obviously the machine powers on, but there is no PP bus. There's no communication to the NAND. Then obviously it's going to start. Now you see exactly what I'm talking. Like we didn't even get to this point yet, but I was just saying that sometimes you might say to yourself, but there's no component here, so which means there's nothing to worry about. But what you don't know is there are printouts there which are communication line. I don't know if you understand what I'm saying. Exactly what I described is exactly what's happening here now. There is no component on that line, but that's a printed line, and that's a line that carries communication through. Now, because of damage in that section, that is there is no more communication between A and B. So what we just need to do is we are just going to run a wire between this guy here and PP boss. Hmm? So we're going to run a wire between this guy and PP boss, and then we're also going to check. Remember, there are two of it. Okay, this seemed to be Audi. This one here seemed to be an Audi 899, which is this guy. This is Audi 899. That seemed to be fine, but we are still going to check it. So what we are going to do is we are now going to we are going to run a wire between this section here and the PP bus. So let's see what's the easiest thing to. Let's see what's going to be the easier place to take it from. So we have PP bus here for NAND, and let's see. So we can take it from here. We can take it from here. We can take a wire from here because let me see. Now before we do that, let's okay, so before we do that, we are going to see, before we take a wire from here, we are going to confirm that this PP bus here is equal to this, correct? Remember, that is this, the other line is an equal to. That's not exactly PP bus. That's an equal to PP bus underscore. That's deducted from PP bus, correct? Now, yes, we know we want to ensure that this line PP bus itself is what? Is still equal here. Do you understand? This is not, we're not talking about equal to now. It's direct. That's PP bus underscore AON. And the other side is still PP bus underscore AON. The reason why we need to confirm that is in case if it's broken. So if you run a wire, you're just running the wire from nothing to nothing. Okay, so let's confirm that. So we intend taking PP bus from this guy. Okay, it's populated. So let's look for what is not populated. Okay, there's something. It's this one here. Let's see, is that populated? Okay, yeah, that's the one. So it's not, so we can take it from here. So that's not populated. So what you're going to do is you're just going to see if this guy here, this PP bus here, is connected to the PP bus there. Okay, that's fine. Correct. So we are going to take it from there, and we bring it to this line. Correct. Okay, and then we're going to remove this guy as well.
The reason why you're removing the thing is this because maybe it's not going to fail now, but
No,
it's
no,
going to
no,
fail
no,
in the
no.
future.
But no, because of that. Can you see that?
Yes, yes.
Okay. Uh, okay. Let's say. Farid, can you see if the mic is still on? Because sometimes the mic is off.
But
Okay. Especially when it's not properly charged. Okay. Okay. So It's and before we're going to remove that, but obviously we just want to first uh, test it. And the reason, ideally, I would have want to remove this before I put this, because obviously when you heating it up, chances are that you burn the wire. But what I'm going to do is I'm going to orient it in a way that the wire is somewhat safe. Okay, so that's that. We are now going to check to see if we have. And then another thing I want to say is this. Now, if you had in the stated way, if you had to use your diode mode, you will see difference, a huge difference, obviously, in what in the numbers. Okay. So continuity. So let's check. Let's see. We take from there again. We take that part, and then we come here. Okay, we have continuity. That's fine. So the next thing we're going to do is let's just make sure we don't have a short on that line. Let's make sure, because obviously because of this cap. Remember, we're still going to replace it, but at this moment we just want to we just want to see if we have if our issue has been resolved first. So let's see, do we have a short? And obviously, this here tells you that that is the main, correct? And this is going to be your ground. Now, usually capacitors you have, they say polarized and non-polarized. So when they say polarized, and polarity is basically, when they say polarity, they're trying to talk about the different branch. So basically, if they say, let me see. So if they say polarized, so this capacitor here, this capacitor, this is also a capacitor, yeah, but this is a non-polarized capacitor. Now, what that means is there is no actual polarity, there is no direction. If I'm replacing this, I can replace it either way. I can flip it either way, it's fine. But these ones that have markings on them, these are polarized capacitor. Do you understand? You have to put them back in that particular orientation. Do you understand? Make sense? Okay, so that's basically just by the way. So and I mean there are many of them, like all of these ones, for example. You don't have to orient them in a particular order. The same thing applies to a fuse. You don't have to align a fuse in a particular order. Whichever direction is fine. The same thing applies to an inductor. You don't have to align it in a particular order. Just show you an inductor. Okay, no, this is an inductor, for example. You don't have to align this in a particular order. However you align it, it's fine. This is a capacitor. As you can clearly see, there's a marking in that's a polarized cap. That's a polarized cap. This looks like a capacitor, but it's not a capacitor, it's an inductor. Okay, that's beside the point. Okay, so we've done that. So now the next thing we're going to do is we're now going to check again to see that we have let's see if we have a stable safe 3. You know it was blinking before. Let's see if it still blinks this time. Okay, so we see that it stops blinking. So what it would mean now, it's now that it stops blinking, we are very sure that now we have a working device. But what you're going to do is you're just going to put it in the shell, test it to see that it's working, and then we will now come back, address that section of the board, remove the capacitor, replace it, and then that will be it. I'm just gonna put it on, and then I'm going to connect the cables that we need for the testing to take place. Please put this down. You can hold on to it. We might still need it. There you go. Put that in there. you you while we're putting this together, sometimes you find clients, you see the concept of what part did you replace? What component? You know, sometimes they say to you, they say they want you to charge them according to the component that you've replaced. Not every repair will require you to replace a component, which is why you do not charge for the work, you charging for the device. So do you understand? The device is a no power. This is so, and then I mean the idea of okay, tell me what component you're going to replace. If imagine if you're telling a client, okay, I'm just gonna run a wire, and they'd be like, and so is that what you're going to charge me for? No, the job is not the wire. The job is how. So the wire is just that's just the finality of the job. The job is me being able to narrow down exactly what needs to be done, and then this wire, anybody can just put a wire, correct? But that's not the job. The job is getting to. How did you come to know that this is exactly what needs to be done? That is the job. That's what you're paying for. Because you might run into clients that say, no, 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 no. Tell me what component that you're replacing and how much is that component. So, my friend, if you want to know how much is that wire, the wire is close to nothing. So that's the idea is not and don't argue with the client because you're not going to win. You just tell the client this is your operational, this is how you operate. You charge according to the job, so not what you did to the job. And also sometimes you also get the questions of how much time did you spend on the device. That is also sometimes that's also a factor, which is sometimes you have the hours, billable hours and non-billable hours. So they say, okay, how much time did you spend on the job? That would determine how much it's worth. Actually, no, because some people have become so good at this that they wouldn't spend that amount of time that you're expecting. And some people will sit with this for a month. They won't figure it out. Especially this is a tricky one because you will say to yourself, usually when there's liquid damage, you expect component affected, replace, correct? But in this case, there's no component in that section. Now you ask yourself, okay, there is no component, I have cleaned it. But then you even ask yourself, but even though there's no component and I cleaned it, what was affected? Because there's no component there. So this is a tricky one. And then obviously you need somebody who knows exactly what they're doing to say to you, yes, there is no component there, but this is, and then this also brings me to this idea of how to, when somebody say how to fix a machine, for example, this is just a one-off, correct? You have been making videos for some time now. You've not seen this type of failure before. No, exactly. So but then we have 16 inches M series for no power, which the approach was completely different. So imagine if you are to say, okay, what you're going to do is you're going to use the approach of you're going to use the approach of one of the ones that you've seen, and then you think, oh, that's the issue. So that's your solution. So it might not be exactly what it is. So each device will obviously have a unique issue, and obviously the resolving it will also be unique. We are going to connect only the cables that we need. Okay, so this cables, it's the more you remove some, you have more that are hidden away. Okay, so we are gonna only connect some of what we need, not everything, because we still have to take the board out. We are gonna have a fan. We can have one of the fan on. We are definitely going to connect the trackpad. We are not going to need a battery because we have the charger that we have is enough to power the device without having the battery connected. We don't have to connect the keyboard because we don't really need that. So what we need is what we've connected. We've connected that, and we can just also connect the one of the speaker. We don't, okay, the fan, one of them. Even though we're not going to connect it, we don't want the cable to break. Let's make sure it's out. Uh, okay, so that's I think that's we have the screen connected. We have the trackpad cable connected. We have one of the speaker connected. We have the Maxi 3 cable connected. So now let's see if we have a working device. It's connected. Did you hear the chime? Yeah, even though it was subtle. So that's it. You have an Apple logo, and that's about it. So obviously, again, you have the track the feedback, and then just something to mention again on your Sift 2 and obviously you hear the fan spinning. The loud fan is because of the fact that there's no battery connected. Correct? That's why that's why you have that loud fan. And obviously we only have one connected. That's why. And in terms of loud fan, if your trackpad is connected and the battery is connected, even if one of the fan is not connected, it's not going to result into having a loud fan. Okay, so loud fan, it's in this particular case is because of the battery not being connected. But as you guys can see, we have a working device. So I'm just going to walk us through obviously uh, so uh, that's basically do you guys have any question? And then the next thing I'm just going to do is already the job is done, so we are just going to address that section of the board, remove that cap, and then replace it. But the job itself, the repair itself, it's done. Do you guys have any question that needs to be addressed so that we can address it? And interestingly, even though you saw exactly, and so this is very important. Even though you might have sections of the board that are not populated, you might have sections of the board that are not populated. Say, for example, it might just be your tip. So here you see that on your board. I'm just going to show you this. It's going to say, see here, for example. So you see where it says test pad, yes? So even though there's nothing here, remember that test pad can be a communication, can be a line can be going through that. So if something happens there, don't say, okay, I don't see any component missing. The test pad itself, make sure that it's so you see this is a healthy test pad, and obviously what we had was a test pad that was not healthy, obviously because of liquid in that section. And another thing I also want to mention is the quick the disappearance of a particular test pad when there is liquid in that section is dependent on the amount of power that that test pad holds. So if the power is very limited, so it's gonna eat up gradual. But if the power is high, in this case it's a PB bus, then it's obviously it's going to be more. So even though we saw that, and it's very interesting, like I said. So even though there is nothing here, so we are also going to check, obviously the device came in for no power, so we're going to clean it up and then remove that cap. That this cap here, even if it's not removed, you can clean it, but just to be safe, we're going to remove that cap, replace it, and then adjust the section, clean it properly, and then the device can be put together. Do you guys have any questions?
Any questions on the charging? So I remember sometimes when you work on it, you when one when say for instance you have four charging ports,
Yeah.
and then both three three stays stable and then the one stays or go on off.
Okay.
So the one that is the three that are staying stable, that is the ones that
These are the ones that are okay.
not the one that goes on, the one that has the issue.
Yeah. So usually the way it works is this. So usually what happens is when it comes to looping, so what will happen is you will have three loops and one stays. Yeah. And sometimes it could be that the one that is looping is the one that is faulty, but 9 out of 10, the one that does not loop is the one that has failed. And then another thing that also, I don't know if you mentioned to him, the device of yesterday, the M1 from yesterday, even though only one of the CD failed, but remember that CD was the one that was connected to the ROM, correct? I replaced it, but it did not work. I had to replace the ROM itself. Do you understand? So sometimes, usually, especially when it comes to CDs, you replace it, you think it's not properly replaced, you remove it and you put in another one. You see the same thing. Then you go to the second one and replace the second one, thinking that has also been affected, and it still doesn't work. But just be aware that sometimes you might have to replace the what? The ROM chip. And The behavior also will be, it's not unique. Sometimes the none of the port will try to boot loop. It's just going to stay on 5 volt. And your problem can be the ROM chip. And other times, both of them will be trying to negotiate 20 volt. It gives you a 5 volt and then loops and then it comes down to 0, 4, 5 and then basically it switches. It's as if it's, but the switching on and off is not it's not rapid. It's not like on a, no, 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 no. It stays and then it drops down. Even at that, you can have issue with it being the ROM chip. So you can reprogram the ROM chip. We have a machine to do that. You can reprogram the ROM chip, or you can just take it. You can take from a known working board that is working. You can take from that and then you put it on. But it has to be the exact same board. Some of the boards they share, some of the ROM chip they share the same. For example, A1708 and A2159 they share the same ROM chip. Yeah, remember, one is two port, 2017, 2017 non-touch bar, and one is 2019 touch bar, two port. So you can interchange the ROM chip. So that's just one of the ones. So yeah. So do you have any other question?
But sometimes when it does that, I think the ones that are staying on is actually
The faulty ones.
the and the ones that are going off. That is what
Fari, do you have any question?
Great. So I was looking at this board as this.
yeah. For me to understand it, the three that is grouping is the issue, and the one that
No.
no, the three that is not, the one that stays on is the issue.
Yeah, the three that is looping are fine.
They are trying to negotiate.
Yeah, the one that is not even trying at all is the one that you need to look into. And these things are not set in stones, hey. Sometimes uh, the wire is out. You're going to put it back. So this is what I was talking about. I was saying I was gonna. Can I have a board to replace that one? This is why I was saying usually you want to replace that first, because obviously it's going to get affected while you're okay. So I'm not gonna put it. I'm just gonna. I'm gonna first do replace that before I put it back. If for some reason I mean, in this particular case, I'm taking it from, but as you know, this is a general capacitor. You can take it from anywhere. It doesn't have to be specifically from an M series board. And remember what I told you about not having to have your hot air fixed in one place. Try to move it because you don't want. Some boards are very fragile, and other boards are not. Okay, that's that. Now we can can have that. Okay, so you guys have any question? If we don't have any question, I'm just gonna clean the board and that's it. And that will be the end of the video. So obviously the next thing is obviously the board is gonna go into testing and we'll put it together, test it just to be sure that everything is fine, and that's about it. Is there any no
But
question? Yeah.
I question that this because this morning when I was checking the sport, so I was looking at PP bus, I was looking first at the PP bus lane and on diet mode, and it was giving me 590 something. Then when I came to check on that PP bus lane, I got 430 something. Because of the connection it wasn't.
No, that's this was a complete break. So complete break is not gonna give you such close. It's gonna be very one is gonna be like OL open line, and then the other one is gonna because this is not a partial break. Yeah. Is there any other question? Hmm?
No.
Okay. So if that's it, okay. Thank you guys. I will see you guys in the next one. Just gonna clean it, and that's it.